Hello coders, welcome to my video. In this video, we'll discuss about a condition that is called a deadlock condition. So the deadlock occurs when two or more threads are blocked forever and our process got hanged up. Okay. So both the threads or the multiple threads are waiting for each of the resource to get freed by the other thread. Okay. So this situation arises mostly in the multi-threaded application in which there is a improper synchronized mechanism that is being used. For example, we are using the mutex. So due to that deadlock condition, what is the side effect of this deadlock condition? Our program got hanged and no process is in the running state. It's all on the waiting state after some time. So in order to avoid this condition, we'll see first how it is being produced. So necessary conditions for this deadlock is first one is a mutual exclusive. Okay, as we have seen in the video of mutex, in which this is mutual exclusive, which means that only one thread can access the resource. For example, if I have a resource or a shareable variable, and it's been shared between the two threads, so only one thread can access that variable at one time, so that is called a mutual exclusive. So the thread can hold and wait that resource until that thread finishes operation on that resource. So once that thread finishes access that resource, the second thread will access that resource. So no two threads can access that resource at the same time. Okay, so that is the second condition of a deadlock. And third condition is no preemptive. Okay, so there is no priority thing in this. Like we have multiple threads and they have the different priorities. So this access is not dependent on the priority. So that we'll discuss on the priority inversion topic. Okay, so then we have a circular rate in which we have multiple resources and that is being accessed by the multiple threads. Even a single thread can occur in this deadlock condition. So in order to have a deadlock condition, we have all these four conditions met. If any one of this condition is not met, it's not in a deadlock condition. So let's start with the programming. So as we have seen in the mutex video, so I'm taking the same example in which I have two threads, thread 1 and thread 2. Okay, so these two threads have been joined here, and we have a mutex as well. We have defined it here, and I have some shareable resource counter, and it is under this critical section using this mutex, and we are destroying this mutex and we are displaying the final counter of this threads function. So when we have two threads, so this function has been executed two times. So if I say here, if I run this program, the counter will increment to 2 and the value we are getting here. Okay, so let's run it first. So I have, okay, deadlock.exe. So the value is 2. Okay, that is fine. So what if I type this wrongly and I make it twice, the same mutex log? So I will print here going to lock the mutex. Okay, and next I'll take mutex 1 is been locked now. Mutex is locked now. Okay, so third I'll take it again, and the third one I will take mute going to lock the mutex again. So just for understanding, what I did is like I taken the lock, I'm taking the lock it again. So this is a single thread. Uh, we are using a single resource, and two threads have been working on the same resource to access this lock. Okay, so I want to check how it works, whether this program got hanged or not. So here I locked it twice, then I unlock it once. Okay, so this has been locked twice. Okay, I want to check now. I'll compile it again and I'll execute. See, so going to lock the mutex. So this print is twice as we have two threads working on this same thread function. So the second is a mutex is locked now. So only one thread is entering here and the next is again locked. Okay. So our program got hanged up here. Why it got hanged up? Because this lock is taken by one of the thread. Okay. So when the second thread came, this is already locked. So the second thread won't able to cross this limit, this critical section. So one thread is already here. Okay. But it cannot lock it again because this is again locked by thread 1, so thread 1 cannot lock it again. So this process is also being hanged by a single thread only. The second thread is not in used. Okay, so if I take only one thread here, okay, if I comment the second thread, we got the same operation. Okay, so we'll see how we got the same operation. So now we have a single thread. I'll save it and now I'll compile it and I take it again. So now this message is only one because we only have one thread. Now there is a mutex lock. So the same thread is locking it again. So this is also one of the condition from mutex lock. Okay. So let's check the second condition. So how it has been removed? We just commented this lock. So this condition, this is an error from our case. So I comment it again. And now if I run it, it will run perfectly. Okay. So the final counter is one because as we have only one thread. Now I will take one more thread function. I'll give it to thread 2. Okay, so this is worker 2 and this is worker 1. Okay, so here what I do, I'll take two locks. So this is one lock. I'll copy it. I again initialize lock 2. Okay, so here I'll take lock 1 for thread 1. Okay, so here I will take lock 2. Now what I will do, I will take lock 2 here as well. Okay, and I need to unlock it as well. So what I will do, I'll unlock it as well. Okay, so the same operation, better I'll copy uh from here, or what I'll do, I will take the lock 1 here and I will take unlock the same. So there I need to change for first thread use worker 1, for second use worker 2. Now I have to destroy worker 1 and the same way I have to destroy this mutex 2 as well. Okay, so this is clear. So the first thread is also incrementing this counter and the second thread is also incrementing counter, but these multiple locks are there. I will do after this first, I will take a sleep. Okay, and next after 2 I will take sleep of 5 seconds. Better I'll take, save it, then I will run it. Okay, what is that? Okay, I have to include a header here, that is uni std.h. I'll save it. Okay, now I compile it again. Now I have deadlock condition to execute. Okay, so you see it's been hanged. Okay, so let's understand what happened here. So this is the first lock. Okay, so once this lock 1 is been taken and lock 2 is by taken by this thread 2. Okay, So then we have a sleep. Okay. But this, after this, they try to use this lock, but this lock is already taken because it's of 5 seconds. So this lock is already taken by this. After 5 seconds, this second thread want to take this lock one, but it's been already locked. Okay. So point is, the first thread lock this lock one, and the second thread lock this one. So both are stuck. Okay. So this way our deadlock condition occurs where the thread 1 is waiting for the mutex 2 to get released, but the second thread want mutex 1 to got released. Due to that, both of these threads are got stuck. Okay, so how to avoid this scenario? So what I will do, if I change the order of this. For example, if I take the same order, first I lock mutex 1, then I lock mutex 2, then I lock mutex 1, unlock, sorry, and then we lock, unlock mutex 2. Let's save it and I will again compile it. Let's wait for the seconds. See, you will get the output final 2. Okay, so ordering of this lock is very important. We should keep in mind whatever order in the recursive, locking we are using, the same order we'll use in the next lock as well. So this is, all about this deadlock condition. So let's see in the next video. Thanks.